Hi, my name is Barak, and I'm the CTO and co-founder at Bridgecrew. Bridgecrew's mission is to enable infrastructure security where code happens, making it easy to automate and remediate issues on infrastructure as code manifests, right from your first line of code, of Terraform, Cloudformation, Serverless, Kubernetes, and other configuration as code manifests. To that end, my topic for DevTalks is developer productivity and how it relates to static analysis of infrastructure as code manifests. We're going to go through a number of practical open source tools that will help you to automate security best practices in your CI/CD pipelines and IDEs. With the main view looking at productivity and having that virtual security advocate experience across every stage of the development lifecycle of cloud native infrastructure.
For the next 30 minutes or so, we're going to talk about developer productivity and how it relates to static analysis of infrastructure as code manifests. On the agenda for today, we'll talk about what it means to have a cloud misconfig in your infrastructure as code framework, the state of open misconfigs on open repositories that can be found in the wild, how we can prevent those misconfigurations using policy as code, and how can we automate policy inspection as part of our CI/CD pipeline. We'll also cover how to analyze runtime instances of cloud resources or Kubernetes clusters. So as SREs, we'll have the entire flow inspecting what's a good state of a cluster or an AWS account, for example, and what's a bad state and how can we go from one point to another. So this is the crew within Bridgecrew, and this is myself, the one that is not looking into the camera here. If you'd like to read more about what we are doing on the open source space around infrastructure as code, you're more than welcome to follow me on Twitter or to grab some of the blog posts on our company's blog, or follow me on GitHub and see what's the open source contributions that I'm making on a daily basis. So as an engineer, I like to write code. I like to build stuff. I like to work on open source tools. And I'm doing a lot of changes that are related to production systems. And unlike everybody likes to think, I really like to move fast and I really hate to break things. So I really want to have a good state of production environment, even though in some cases that's not always the case. And in some days, I have a love or hate relationship with a specific tool, and this tool is Jira. I don't have anything against Atlassian or the company or the product. It's just that some of my days looks like this. Or another engineer opens a ticket telling me not to admit root containers running on production, which has multiple reasons. I don't want to escalate privileges to users, and I don't want users to do malicious activity on my containers in production. And I do not want to admit containers to share the network host namespaces. I don't want to have any network issues or collisioning. And I also don't want to have port 22, which is SSH, open to the entire internet, so everybody would be able to SSH given a key into my production workloads. And I have a lot of those tickets coming in on a daily basis, or at least I used to have those until I decided to develop a solution and open source that. So it's not like I don't like Jira, but just in some cases, I get so much noise into my backlog, into my sprint planning, that I can never get anything done. I just get more and more tickets, more and more security issues over configuration changes in my YAML of Kubernetes or in the HCL, the HashiCorp language of my Terraform file. And it's the same story for the entire team. We're just bombarded by security with a lot of tickets to be resolved, most with a good reason. So as a startup, we have a very limited resources. Also, big companies have those issues. And we have lack of experience in some cases. It's not symmetrical among all of the engineers. And we needed help to share that knowledge of how to create secure by default cluster or cloud environment. And we wanted to democratize that knowledge and to distribute it across the organization. So before telling you about the open source tools, let's see what a misconfigs look like, and let's look at some data. So what we did is we scanned almost 2,000 infrastructure as code open source modules around AWS only. Those contained 50,000 infrastructure as code files. And what we found is that almost 1 in every 2 open source modules are misconfigured. So if you're taking a module from Stack Overflow, linking to a GitHub repository, and you're just doing copy paste like most of us do, there is a almost 50-50 chance that you'll fall on a misconfigured by default module, and you'll have to play with some of the variables to make it secure by default. And how many downloads did those modules had in 2019, which is when this research was performed? 10 million misconfigured provisioned instances are out there, or instances or IAM policies or security groups, different resources in the cloud. And that's a lot of provisioned misconfigured resources. And the types of misconfigs are, hey, you don't have logging enabled by default for some of those, you don't have backup and recovery, you don't have encryption, generic Kubernetes issues that we'll dive into, networking issues, some IAM issues. And by that point in time, when this research was performed, we saw a specific spike in amount of contribution to open source modules, which is great. Everybody wants to have more open source modules, more open source code, more free code to be utilized across companies and collaborated within the community. But with the effectiveness of COVID, where everybody worked from home and were more productive, we had a spike of people contributing more and more open source modules. But with those modules contributed to the open source, we had also a almost symmetrical spike with the amount of misconfigured resources in those modules. And if we'll dive in just into the type of misconfigurations in Kubernetes, and some of them are more opinionated than others, we can see that some public endpoints are accessible to the entire internet. We have secrets that does not have encryption enabled. We have issues with logging, etc. So how do we suggest to solve that issue? First, by stating that having all of those configurations staged in code, it's actually not only a risk, but it's more of an opportunity. For the first time, a lot of those configurations are not managed manually. So in the past 7 years or more, we had Ansible, we had Puppet, Terraform, Chef, Cloudformation, Kubernetes, Serverless, ARM templates, and more that enabled us to version control our configuration, and by that collaborate on changes. That way, we don't have more tribal knowledge in our organization, or we have less tribal knowledge in our organization. And once those configuration changes are staged in Git, we can actually inspect them and roll back or fix them as part of a review process. So Terraform and CloudFormation and Kubernetes enabled me to say, here, for example, I have an S3 bucket configuration. And the only thing that I miss to have backup and recovery enabled on that bucket is to add those lines of code in green, enabling versioning on that S3 bucket. And if I want to restrict public access and I don't want my bucket to be publicly accessible through the entire internet, what I need to do is to add those 2 lines of code that will tell me, hey, I'm restricting public access to those buckets. You know, it's a similar configuration in a slightly different syntax on Terraform to enable versioning. And in some cases, some of the changes are even scattered across multiple files, where I have one file determining how a template of a resource like IAM resource should look like. Over here, I have an IAM password policy, and another resource telling me how it should look like before deployment on my variables Terraform file. where I can, as an engineer, inject the right values for each and every environment, or just manage defaults on a variable console. So we had infrastructure as code for a while, but we didn't have that experience of an advocate telling us, hey, this is really the best practice. You should change from without versioning to with versioning, or from having password policy at the length of 8, you should really have the length of 14, which is what the best practice that the CIS framework is recommending. And in Kubernetes, the thing that I really need as a security advocate is telling me, hey, the security context should never run as root. You should not run root in your container. And you should not override that specific configuration on specific containers. It should be symmetrical across the cluster. So this is why we've decided to open source a tool named Chekhov. So Chekhov was created on 2019, the end of it. It already has more than 80 contributors. It's under the Apache 2 license, more than 1 million downloads on its first year, and more than 2,300 stars. This project is highly maintained by the community, and it has today more than 700 and something best practices that comes with Chekhov. So you don't have to write policies by yourself, like, does my bucket have versioning enabled? No, you already have those best practices embedded inside. Most of those policies were actually contributed by practitioners in other companies, not Bridgecrew, not only Bridgecrew, by best practices that they see in their own organization. So Chekhov has the power of the crowd, where developers in various companies say, hey, this is a best practice, and they decided to contribute it to Chekhov, which is a hub of best practices and policies. Chekhov can analyze different infrastructure as code manifests, Kubernetes, Terraform, Cloudformation, Serverless, Helm charts, and even in some cases CDK. When you synthesize a YAML from it. And it gives a very clear CLI output. And it also has various integration with CI/CD pipelines such as Jenkins or GitHub Actions. So what is policy as code outside of a best practice telling me not to encrypt, not to forget version control or encryption? It's actually more than that. It's the ability to collaborate and version control of a best practice. So let's say that you have in your organization a best practice where each resource tagged with an environment name equals production. You want it not to be attached to a security group that is public. You can actually do that, and you can create that policy, share it with your peers, and they will tell you, hey, it shouldn't be available only for production, but also for the data science environment or other environments that have sensitive data. So it can be peer-reviewed. It can utilize inheritance. Chekhov is written in Python, so we actually integrated some cool tools that does IAM analysis with Chekhov, and by that way, we prevent, as a policy, privileged escalation capabilities on IAM policies. And it can be, as a CLI, integrated to the software development lifecycle in different stages. It can be a VS Code extension, it can be a pre-commit hook, a CI/CD runner, a pull request reviewer, and it can even analyze some of your production workload using the same set of rules. So it can actually be part of your CI. So this is how a simple Kubernetes policy looks like. We have a best practice telling us, hey, CPU limits should be set, both on containers and init containers within Kubernetes. When creating a Kubernetes policy, I'm just determining the ID of that specific policy, the name and the supported kind of resources. And the thing that I'm doing is inspecting whether CPU limits exist within the Kubernetes configuration or not. If it does, if it doesn't, I fail. If it does, I pass, which is great news. This way, I'm enforcing each and every configuration to have the right CPU limits available before deployment. So let's run a simple demo. The thing that I'm going to do now is I have a set of misconfigured by design repositories. There are 3 repositories that I actually like to use to play with infrastructure as code static analysis tools. One of them is TerraGoat. So TerraGoat is a vulnerable by design infrastructure as code framework, which enables me to provision a set of resources that are misconfigured. Do not try to do that in production. And you can deploy those misconfigured resources across all of the different cloud environments, AWS, GCP, and Azure, the main 3 cloud providers at least. And you have sister projects, which are CFN Goat, the same concept just on Cloudformation, and CDK Goat, and also another cool project called Kubernetes Goat that has specific scenarios and best practices and a great walkthrough of how to have a misconfigured by design Kubernetes cluster. Again, never deploy those on a production environment because they have a misconfigured by design public resources, databases, etc. But it's a good practice to use those on a test account and to see that your security tools can scan and analyze those misconfigurations. So the thing that I'm going to do now is I'm going to use an already cloned repository. Let me share my terminal. So over here, I have already downloaded TerraGoat, which is just typing git clone. And I've already installed Chekhov, which is super simple. It's just typing in pip install Chekhov. After installing Chekhov, the capabilities that you have are possible to be viewed via the help flag. So Chekhov can analyze a whole directory of infrastructure as code files, specific files. It can load a set of external checks, a custom check written in Python or YAML. And it can give various formats of output. It can, those output formats can be JUnit XML, JSON, GitHub Markdown, or the Cloudformation CLI output. Those different outputs will enable you to have different experience across the ICD pipelines. For example, if you have Jenkins enabled and you have the JUnit XML plugin, you can actually view a full report of the Chekhov output. So let's take a look on how a simple output looks like. Over here, I have a clone of TerraGoat. And in this clone, I have a directory of AWS, GCP, and Azure. What I'm going to do now is I'm going to see what type of files I have here. And I can see that I have a Terraform file for each and every type of resource that is interesting to me. Let's take a look on how the S3 Terraform file looks like. So I have here a data bucket, a data object, a financials bucket, and each one of those have various issues. I've written some of those in comments. This bucket is not encrypted, it does not have access logs, etc. Why is it important to have my bucket encrypted and to have access logs? Just the best practice that if I want to track who's accessing what object and when, I need to have access logs enabled. And if I want to have a custom encryption key for compliance purposes, I can set that up by configuring encryption on that bucket. Let's run Chekhov and see what it can give us on top of the AWS directory. The thing that I will do is I will type in Chekhov -d, which stands for directory, choose the Terraform folder, AWS, and see how the output looks like. Chekhov will now analyze all of the different files that are available and will categorize those to passing and failing files. I even have a parsing error because I've written some bad code in my Terraform. So I have here 40 passing checks and 32 that are not working, that are failing. meaning I need to fix those 32 resources. So over here on the DB app Terraform file, I have a security group that does not have SSH port enabled to the entire internet, which is great. I passed this test. Let's take a look on some of the failing tests and see how we can fix those. I don't have logging enabled for Neptune, and let's take a look on what's the status of my S3 buckets. When we scroll down a bit, we'll be able to see problems that I have with security groups. And here are some of the problems that I have with buckets. For example, I don't have versioning enabled, and over here I have even a worse problem. I have an AWS provider with plain text access keys configured on my code. So those various issues are problematic for me. And in some cases, I have even parsing issues that I should solve because I wrote some illegal code. So let's, before this meeting, I've edited one of those files. Let's type in git status. I have an S3 file that is modified. And the thing that I'm going to do is I'm going to try and commit one of those files because I've configured a pre-commit hook that will pull down from the checkoff repository, the pre-commit hook configuration, and will actually run checkoff, meaning if I don't have a best practice in place, if I have a bad practice in place in one of the change files, the commit will actually fail. So I'm going to try to git commit -m. Let's type in clear before that. And say test Terraform change update S3. The thing that it will do now, it will actually run checkoff, and it will prevent a commit from happening if I have an issue within my environment. So checkoff is actually running and analyzing each of those different files. It's failing because I need to fix some of those files. And I have the details for the passing checks, and I have the details for the failing checks. If I want to know and understand how can I fix those, I can copy that specific configuration and type it within my browser. And I have a full guideline of how to either fix those in Terraform or through the AWS console and the rationale behind it. So each and every check have actually a guideline that is maintained by the open source community and the Bridgecrew team to help you as an engineer to solve those different issues. So you have a fast feedback loop. Right before you're committing those to a shared GitHub repository, you can have those reviewed locally by checkoff and telling you what security best practice you should have in place. So the flow is, hey, I want to do a change. I'm running checkoff as a pre-commit hook. And then I have a deployment trigger if the code is working and is passing my infrastructure security tests. And I can apply it into a destination account within one of the main cloud providers. So what's the next stage? The next stage would be actually to have checkoff as part of my pull request, because not all of us have a pre-commit hook deployed on our endpoint. And also some of the changes can be done directly through GitHub. And each one of us are doing, in some cases, a forced push to GitHub, skipping a pre-commit hook that could have prevented a misconfigured environment. So the thing that we can do next is actually to have a GitHub action. We have a GitHub action for checkoff that will scan as part of a CI/CD pipeline those different issues. So the thing that you'll need to do is you go into checkoff action. It's also available on the marketplace under the Apache 2 license. And you need to configure the checkoff action in a way that will tell you, the action, what check IDs would you like it to run? Would you like it to run all of the different checks? Would you like to give an output with failures and passing, or just one of those? and what's the supported output format and debugging level that you would like to have. So once you are configuring the specific GitHub action, you can actually see, I'll show you one of the example outputs. In a sec. Where Mike have created a change within code, and you actually have the check of action failing the build with the specific details of why it's passing or why it's failing for a specific issue that Mike have created on top of the Terraform code. So now we have Chekhov as part of our pre-commit hook on each and every developer's endpoint, giving us as developers fast feedback, but also as part of our CI/CD pipeline, telling us, hey, you should or should not really deploy those resources into production. So since we don't have a lot of time, the last part of the demo would be, how can I actually monitor my runtime instance of Kubernetes cluster? You can actually take Chekhov and run it as a cron job within your cluster. And Chekhov will actually pull down the configuration of the running cluster, and will scan those, and those Kubernetes resources within your runtime cluster, whether those are version controlled or updated through kubectl, will be inspected in Chekhov and will be printed into the Kubernetes logs. So you'll have a continuous assurance of your runtime configuration within the Kubernetes cluster, that you have best practices in place. So the entire flow would be have Chekhov on pre-commit, have Chekhov as part of your CI/CD pipeline, and also have Chekhov as a running container within your cluster, doing runtime assurance of those configurations, and notifying you, maybe on Slack or PagerDuty or another notification system, if you have any security issues on a cluster that is being modified manually by the SRE team or security team or malicious activity. So you have those three stages of pre-commit, continuous integration, and runtime scanning, which would be beneficial for you to have the analysis on all of those. Another way would be, if you're using VS Code, is just to use the VS Code extension of Chekhov, which is also open source. And it can actually analyze misconfiguration issues and fix those if you're using API key, and help you to do the same analysis that is available through the guidelines within your VS Code, meaning within your IDE. By that, you'll have the different stages of the software development lifecycle. The left you are, the IDE, is the more productive you get because you can solve issues on the individual level before exposing other teammates to the issues that you've created, saving time in code reviews, saving time in CI/CD pipeline. So having those capabilities of scanning misconfiguration within VS Code actually helps the productivity of the entire org. It saves not only the tickets in Jira that are about to come, because you're fixing the issues very early on, but it's also fixing the time of build and the time of code review. And the same can apply on pre-commit. The idea is just a better experience because you get those issues as you code and not before a commit. The next capability would be a pull request before deployment, or on an early stage like a unit test, or right before deployment, where you can analyze both the code and the plan file, or runtime analysis. So the upside of the right side is it has the most context, because if in runtime you know what actually is configured in production, whether it is defined in code manually or in scripts. And on CI/CD pipeline, you have the context of maybe other modules that is being imported as part of a CI/CD. And on IDE, your main context is actually only the file that you're currently editing. So the availability of information is more accessible on runtime environment, but the complexity and time reduction and risk is being saved more as you save those issues early on. It's like any development lifecycle of application. The earlier you fix a problem, the earlier you design a solution, and you have a good solution, the better it will be and cheaper it will be for maintenance along the way. So the infrastructure as code security and policy as code is just in the beginning. And what I wish we would have maybe in a year or 2 or 3 from now is a world where security and infrastructure are developed in the same place and developed at the same pace at the same time, where issues can be prevented from being deployed if you have those pre-commit hooks analyzing your infrastructure as code before applying a change to production. And where security is not, for developers, is not only a set of JIRA tickets, but actually a business enabler, a thing that they can learn from and get evolved from. And when we're looking on the different analysis that we've done on open source repositories, the main lessons and takeaways would be, hey, we should all keep our manifest secure, whether it is open source or closed source. It's better to have a fast feedback loop than no feedback loop. And it's better to have a fast feedback loop because it will save time to the runtime issues and triage in Jira. It's better to monitor both build time and runtime to have the entire context of your cloud environment. And it's always great to version control your policies in a way that you can collaborate and agree on as an organization that those policies are good for you. So thank you, DevTalks. I'll be available here over chat, or if you would like to reach out offline, you can contact me over email or our open source community Slack. If you have any question about Checkall or would like to make an open source contribution or TerraGoat or other open source tools that we maintain, I would be happy to help. Thank you, everybody.